What we're going to go over, as Matt mentioned, is the intelligent antenna system. And it's something that we've been having for a while, but I'm not sure if the partners know more about it and the details of how it works. So that is the whole point of the webinar. So in introduction of it, this is actually a picture of it. It's a 19-inch rack mounted unit. It does work with a BSR, which is, in this case, it shows a 415, which is licensed. But as I would discuss within the presentation, it will work also with the non-25s, which is unlicensed frequencies. So the dual operation is the IAS has a connection to an antenna, and two totally independent radio systems communicate through that same antenna. The legacy is more of a competitive product, like a GEMDS or 4RF, could be connected at the legacy connection. And then our radios, if it's the 415 or the non-25, as the other system. It uses seamless switching. So between the firmware that is internally, it will automatically switch the systems to share the antenna depending on the network and the polling of the nodes on the network or the remote radios. So that comes to the smart monitoring. It has smart firmware that it'll automatically scan both systems and know which one has whichever nodes on the network, which the node would be the remote radios. So there's no reconfiguration. It automatically will scan the network and update it. So as you go through and replace the older radios with our radios, the smart monitoring knows that, and it'll automatically scan the correct radio. So within it, it integrates it, but it uses Modbus protocol to do this, and it uses Modbus RTU. So the BSR, which works in conjunction with the IAS for licensed radios, but you can also use a 415U2, and on unlicensed, it has that firmware built into the non-25U2 also. So you connect it via the RS-232 or Ethernet, and it has the actual firmware built into it. So the upgrade process is to install one of these units with the antenna, so the IAS, and with a BSR, or as I mentioned, a 415U2 or the non-25U2, at the base radio. You connect your SCADA computer that's scanning the network via Modbus, and you connect your legacy base radio, and then you make sure that that base radio is functioning correctly. Then you connect your Condor 415 or non-25 and gradually start replacing the radios, and the IAS will automatically detect via Modbus which radios in which system use the antenna to communicate back and forth. So here's the little network architecture. So within the green is the IAS, and it literally is switches where on the left side is a switch that is actually our coax connection to the antenna. You connect the coax from each one of the base radios, and then internally they have switches that will switch between the communications of the radios to the SCADA computer, or DCS or PLC. So for example, let's say node 4 right here on the legacy network, we're going to replace with a 415 or a non-25. What you do is you turn it, the system off, You do the wiring of the new radio, turn it back on. The smart monitoring will detect that, hey, number 4 has swapped from the legacy system to the new LPRO system, and it automatically will scan whatever data is being passed over the radio to the SCADA system without any blip. And as you go through, you can change out node 1, 2, 3, 4, 5, and at the end of it, everything will be LPRO radios, and all the legacies would be replaced. The firmware is constantly monitoring it to determine who's on which network and converts it over. At this point, really, you could do away, you don't need the IAS or to control anything, and just connect the antenna directly. So you can actually, we talked about this as leasing an IAS for conversions, or you can use this again on another project. So for you guys as partners, you can actually make money by converting over systems by reusing IAS to convert from older legacy systems to our product. So here's a system functional diagram where you have your SCADA computer or PLC. It's connected to a serial port, which then is connected to the router. Within the router, you have 2 ports, and these are software ports within it via Ethernet that you would set. So, and I'll show you the configuration of this, is when you're setting up the communications in the IAS, you need to let it know what the master port number is. You set up all your baud rates and everything for the SCADA computer. Same thing on the port for the slave, but it's being used for the legacy system and also the new LPRO system. So within the legacy system, you set up your RS-232 settings, you put the port number of the router within there. Same thing with the LPRO, but what we use is Ethernet over the air. So we're using a multicast pipe manager to where we're pointing to that port number, and then we send that information over UDP connection out to our Condor radios. So within the router configuration, this is the port number 1, well, master port, which is 6001, and then the slave port. You enable it, and then you set these, but then you have some timing that you have to work out where you would just use the default timing, and if you, when you're setting this up, need to adjust it, you adjust it. Within the SCADA computer, you have that connection to where you can connect it via RS-485 or a serial connection, or Ethernet. So if you're using a serial, you set up your baud rate, your data format, and notice this port number is that 6001, which is the master one. If you're connecting via Ethernet, you would select none for the RS-485, but then you set up the Ethernet connection, which is that master port, and then also the slave port in your IP address. Within the legacy system, you would set up your serial connection settings, and then you set this port up here, which is that secondary port that is in the IAS. But then physically, on the front of the IAS, you would connect your serial connection. They do have an indicating light when you power it up and it's communicating and you have everything set up correctly. It will show you the LED active and start blinking and communicating to the system. As far as the BSR, which is the base station with repeaters, It literally is a 19-inch rack, just like the IAS, but it's really two 415s in there. As I mentioned, and I'll mention again in the question and answers section, you can use a 415U2, and then also you can use on a unlicensed system a 925. So within it, you do multicasting over Ethernet using UDP. But remember from my the configuration of the IAS, that secondary port number is 6002. You set this, you have an IP range port number for all your radios, our radios, the Condor system. And what it does is it goes over and broadcasts the information over the network over Ethernet, because our radios are Ethernet based. Same thing, you connect your cables and everything, and then they have indication lights to let you know when it's communicating everything. As far as redundancy, because the BSR has two 415s in it, literally in a 19-inch form factor, it can be used as redundancy. So at the point that you have converted everything over from the legacy system to the Condor system, you can keep the BSR in there in the IAS as a redundant system. But then if you don't choose to do that, you can have a non-redundant system and you wouldn't need the IAS any longer. So I'm going to just go through 5 questions that I came up with, and then open it up for questions from you guys. So the functionality of the IAS, can the IAS function without a BSR? And as I mentioned before, yes, it can. The IAS is pretty much a RF switch used to switch between the two systems and sharing the antenna with the smart of the firmware that is built into the BSR or a 415U2 or on unlicensed systems, the 925. So it has in the firmware the Modbus Learning and smart monitoring firmware that pulls the remote nodes, and it knows between who is the legacy radio and who is the Condor radio, and it will switch over who's using the antenna to communicate to the remote radios. So the question 2 that I came up with is, what radio manufacturers can the IAS migrate? Basically, any manufacturer which has a licensed or unlicensed frequency radio system with a serial port communicating Modbus RTU. The ones that we have seen is GEMDS and 4RF for licensed systems, but for unlicensed, see a lot of the GEMDSs in FreeWaves, but it can be others. But what we need to do is, if you do have a system that could use the IAS, we need to get with engineering, verify the radio system, make sure that it's a good fit for it. The third question is, can you use the IAS to convert our 905UGs into 1, 2, 3, and 4? So no, I asked this because this would be a nice solution for that. But because it's older technology, that's 20, 25 years old, it doesn't have the Modbus polling when they designed the radio. It has a separate, as they call field bus communications, that it communicates to, like a SCADA system. So you can't do that. We will have to still use what we already have gone over for a webinar and some of my support calls to use the 925U2 in legacy mode. So as far as redundancy, while I have y'all's attention, I wanted to go over redundancy that you have for the 245 and the 945, and then also the other Condors. So with the 245s and 945s, they're a radio modem, and yes, you can do redundancy with it, but but the problem is it's using Ethernet, and you cannot have a loop back, create a loop with it. So when you set up two radios on the same system, you create a loop. You can combat that loop, and Ethernet networks do not like that because they'll, really shut down the system. So to prevent this, you can manually switch over the Ethernet port from one modem or repeater to the other, or what we have built into it is a technology called spanning tree protocol, which combats loops. And what it does is when it sees a loop, it has technology that says, hey, I see this. It allows it to communicate to the first node. And then if ever that other node goes away, it will connect to the redundant node. But it backs off and does its calculation or communications to allow those two to run at the same time, and it takes a little bit of time to reinitiate the communications. So when that comes up, it can take about 30 seconds, and depending on the system, it could take a little bit longer. So we have it built into it to be able to do redundancy with the 245s and the 945s. As far as the Condor radios, which mainly would be the 415s and the 925s, if you look in the C-config, they have a tab for redundancy. And the way it works is you have two radios as the base radios. So you have a primary and secondary. The one that you select as primary, there's three ways that you can set this. And for redundancy to work, it needs to know who is primary. So you can manually do that by selecting, and it shows you this within the configurations. You check this box right here, and it will look at the DI1 on the front of the primary radio, base radio. If you wanted to do it via boot up, you would not, neither one of these, it's only one checkbox for these. The primary radio would be set when the radio boots up, and it knows that way. The third way is similar to the DI1, but it's actually a register within the radio that you can set via a HMI, a PLC, or SCADA, and that's internally into the memory map of the radio. And that is it. So it's a really short webinar, but we wanted to get to present this to let you know this is an option that is out there. But if Matt, if you wanted to open up, if anybody has any questions, I'll be glad to answer.
Okay. Don't have any questions as of yet that have come over. And while we have this time, if anyone has a topic that they would like Kevin and I to present on in 2025, we're open for suggestions. I'm more than happy to accommodate. So feel free to reach out to Kevin or I, and we can add it to the calendar for next year.
Yes, so just to let y'all know, Matt and I, I'm going to be meeting him next week and going over this, and we're going to, set up next year for the webinars. And what my idea is I'm going to focus a lot on applications to apply our radios, our cellular modems, and then our next gen radio, the Quantum. It's going to be a very exciting product. It's going to have a lot of newer technology built into it. But if we don't have any questions, the other thing is Matt and I have 2 of these units, and if there's a need, we have some that we can set up and show you guys. For this presentation, I usually like to have a live demo, but I don't have competitive products to be able to do that, so I wasn't able to set up a live demo. So I did it via slides for the discussion.
Still no questions at the moment, Kevin, so.
All right.
Well, I want to thank everyone for attending. We will have this recorded and added to our YouTube channel within the next week or so, once the edits are done. And I will send out a notification when it does post with a link to the YouTube channel that El-Pro hosts. Give it just another minute or two, see if anyone else has any questions. Well, again, I appreciate everyone's time. And Kevin, thank you very much.
Yeah.
And-
Thanks, guys. And you guys have a happy holidays, because it's that time of the year.
And if questions do arise, I believe everyone that's on this that attended has our contact information. So please don't hesitate to reach out. All right, everyone. I
All right.
appreciate your time. Thank you.
Thank you.